Hello everyone. Today we're trying out a way of learning chemistry by doing a chemistry paper. Um, I'll be explaining why the answers is as such. So we start off with the MCQ first. So this is a O-level paper for 2020. So the chemistry questions start from number 20 if you are taking physics chem. Let's take a look at the first question and understand why is the question as such. Which apparatus is used to collect a gas that is soluble in water? So let me highlight a bit. So if it's soluble in water, can you please highlight yourself, soluble in water and less dense than water, less dense than air. So what are the what are the inference you can get from such a statement? So pause for a while every time so that you can um, get the answer. Yeah. Okay, so if it is soluble in water, that means the gas that is produced should not touch any liquid or water. Why? Because if the gas is bubble into water, it will dissolve in the water. And if it's dissolved in the water, you can't obtain the gas because it's already inside the water. So when you say soluble in water, that means this B and D cannot be the answer because you cannot collect the gas. The second clue comes from less dense than air. Less dense than air means it will float. So, for example, if the gas comes down here, and then what happens is that it will float. If it floats, that means once it comes out from the bottom of uh, bottom of uh, the tube, it will float up. And if it floats up, then of course you can't collect the air. The only possible answer is C because when it's displaced from the delivery tube here, the gas gets trapped on top of here, and as the more and more gas is being displaced, so more and more of the hydrogen gas, for example, get accumulate over here and slowly push the original amount of air over here to be out. So the answer is C. Second question, which method is used to obtain potassium chloride potassium chloride crystal from an aqueous solution of potassium chloride? It may look very difficult, but actually it's not. Again, I pause for a while to let you think. Okay, so this method is to use to obtain potassium chloride crystals. The crystal may throw you off the um, line of thought because you may think something like crystallization. Okay, so but you think carefully, but read the whole question and you can find some answer. There's no crystallization here, right? There's no crystallization. What is very similar to crystallization? Okay, and let me finish everything first. From an aqueous solution of potassium chloride, that means aqueous solution of potassium chloride means a solution. So potassium chloride is soluble in water. Okay, so if you want to know why, there is a table saying that all sodium, potassium, and ammonium salts are soluble in water. So in this case, this salt is soluble in water in the solution. It is as if I change the question to which method is used to obtain, okay, obtain sodium chloride crystals from an aqueous solution of sodium chloride salt. How on do you get the salt? Can it be by filtration? Of course cannot because the dissolved salt will pass through the filter paper, right? So you cannot collect sugar from sugar solution by filtering it through the filter paper. How about fractional distillation? If you say fractional distillation, then you forgot what is the purpose of doing, what is the function of fractional distillation? And you can know that it is to separate two mixable liquid, right? And the two liquids are soluble. So for example, ethanol is soluble in water. So you have two separate two liquids with different boiling points. Uh, Paper chromatography. Paper chromatography, if you can remember when you're in Sec 3, right? You think of it as ink and dyes to separate. Yeah. And if you want to get the crystal out from the solution, maybe you can get a very tiny amount of the potassium chloride stored on the piece of paper, tiny spot. But in this case, if you look at the whole question in total, the answer has to be evaporation. Okay, because this is too little amount and we associate this with um, inks and dyes. Okay, so there's and furthermore, crystallization and evaporation is very similar. Then you may ask me, how come I don't use crystallization? Well, you can do use crystallization, but then it's very slow. And because it's a potassium and sodium uh, salt, the melting point is very high. So evaporation will not decompose the potassium chloride salt, so and so-called crystal. So um, yes, evaporation is the best answer from among this four. Okay, number 22 is typical QA questions. QA question. Okay, and for QA questions, you need to take the reference or get the reference from your qualitative analysis notes. Let me pull it out. Yes, so this is a typical chemistry practical notes, right? Okay, let's think for a while. What are the reagents that we use? So a solution tested different reagents, and we have aqueous ammonia. Aqueous ammonia is to test for the cation. Dilute nitric acid plus silver nitrate is to test for chloride. Silver nitrate is and barium nitrate is to test for sulfate. And this one is also testing for um, testing for cations. So from this from this clue here and the white PPT, I know that is testing for sulfate, and there is sulfate here. I think it's over here, right? You can see testing for sulfate, nitric acid, and barium nitrate. I should have seen a white PPT. Because I see a white PPT, therefore it implies that the solution contains sulfate ions. So there is sulfate ions. Okay, there is something sulfate in next one. You must look for the one that has sulfate. B and C, B and D sulfate. Okay, so it cannot be A and C. Why? Because chloride. Can you see? If we do this, there's no visible change. That means there's no PPT. Remain colorless or remain whatever color it is. But in this case, no visible change means no PPT. No PPT means no chloride because you added this, right? You added this. So take a look again. Silver nitrate. Can you see that? White PPT, if there is chloride, there should be white PPT. So because there's no white PPT, therefore there is no chloride. Okay, let's look at the zinc. At aqueous ammonia, there's no visible change. And white PPT, that's insoluble in excess. So let us see. Sodium chloride here, right? Sodium chloride, so you have to look at the sodium chloride. You have to look at the um, sodium chloride. Okay, we have to look at the sodium chloride column, not this column because as sodium chloride, this one got this one would will give you a white PPT insoluble in excess. Oh, I saw this one. Insoluble in excess, right? This one. Yes. Zinc is white PPT soluble in excess with this respect. And so what do you have? What do you think? Oh, it looks like this is the correct answer. Right? Cannot be zinc because for zinc, if you add sodium chloride, it's quite pretty soluble in excess. Aqueous ammonia, no visible change. Of course, fluoride and calcium, no visible change. Right? No visible change. Quickly, we go to number 23. Which statements about isotope? Okay, forever question. What's the meaning of isotope? Atoms of the same element with the same number of protons but different number of same number of proton but different number of electrons, right? Or should be different number of but the same number of electron shells. Okay, let's look at this question. I think they have different number of, they must have the same number of proton, right? Isotope means same number of proton but different number of electrons. But I don't think I can find an answer here saying that they have same number of proton. But this one, yes, it looks very similar to what you have learned in the textbook. Okay, I tell you why. They have different number of electrons. If we have different number of electrons, that means the two atoms will have different number of protons, right? So A is not a answer for isotope, but it looks like A is the definition for ion. So because an ion is formed from an atom, and the ion, whether it's positive, it has still have the same number of protons, but different number of electrons. So maybe if it has lost electron, or maybe it has gained electron, it is a non-matter. So A is not an answer. They have different number of electron shells. That means different number of protons, right? But the same number of neutrons, which is the not an answer. Isotopes should have the same number of protons, in other words, same number of electron shells. So maybe you can write this out. This is a very unique answer. So same number okay, so for example, proton, let's say we have a proton is 11, okay, 11. So if this proton is 11, it's 2, 8, 1, sodium, right? So 3. So isotope 1 for isotope 1, okay. For isotope 2, it's the same. Okay, the protons should be the same number of protons, 2, okay. This is for isotope 2. In this case, I'm talking about sodium, okay? That's why it's C. Element A is a metal, element B. So metal and non-metal. Alright, metal, non-metal should be covalent, right? No? Or ionic. Yeah, so metal and non-metal should be ionic, so it's either C or D. And yes, uh, of course, of course, is this the correct answer? No, right? Because we all know that ionic compounds have a high melting point. Number 25 is interesting. The element acts as electronic for configuration of 2, 4. Now, what can you derive from here? What can you derive from here? First of all, we should, whenever you see such a thing, right? Can you do this? You write for yourself this electronic configuration. Can you tell me something about this? Can you say something like that? Period 2, right? And group 4. Group 4. Any question? That matter or non-matter? Can you see this or infer to this? The second one, if you see 2, 6, what do you think? Period what? Period also 2, am I right? And then what do you think? Group what? Nowadays they don't call it group 6 really, right? They call it group 16. Right? Oh, someone said I make a mistake. It's not group 4 already, it's group 14. Okay? Group 14. And what else? Matter, non-matter. Agree? Okay, so what do we have now? So non-matter. Okay, so we have non-matter and non-matter. If it is matter, non-matter, then it's easy, right? Because you can do the charges and then you can do a crisscross method to find the formula. So in this case, what do you think? Group 16, group 16 to 6, that means it needs another 2 electrons. One way to do, then we know it's a covalent compound. But okay, maybe why you can give yourself more clue. So what element is this? Is it carbon? Yeah, how about this one? Give yourself more clue. This must be oxygen, right? Okay, you get more and more clues, right? So you got so many clues here. Oh, carbon and oxygen. Carbon and oxygen. What is the very common covalent compound that you can find? There's one between carbon and oxygen atoms. Isn't it carbon dioxide? Carbon dioxide, right? Yes, you are correct. So very simply, carbon dioxide is the answer. CO2. Next question. Calcium phosphate has a formula. In this case, it is definitely ionic compound. I see metal, non-metal. And can you see a 3 here and a 2 here? Yeah. So if we do the crossing charge method, where did the 2 come from? Calcium, right? And from here, 3 must come from phosphate. So is it 3 minus or 3 positive? Okay, it's 3 minus because calcium is positive, it's a metal, phosphate is a polyanionic ion, so it's 3 negative. Okay, a good revision for your uh, calculations. Formula, sorry. Let's look at this one calculation first. Let's say you have this as your calculation. What would you do? Let's say you do not know how to do this. Then what happens? You skip. Okay, I pause here for a while. Let you think. Okay, so 27, if you find it difficult, is because you didn't remember this. Can you see the formula below me, the one you write? Okay, so let me do a very brief um, recap for you. Concentration can be expressed in 2 ways, either moles per dm cube, or grams per dm cube. Okay, there are two. It's just why am I talking? I'm talking that, for example, I ask you length. Length can be expressed in meter or centimeter or even in yard or kilometer, whatever. Right? There are many ways to express the same thing. So for concentration, you either express in zero point moles per dm cube or grams per dm cube. And what's the relationship between grams and grams? So there's a simple formula called like that. Okay? So zero, if you want to express in gram per dm cube, you need to take the moles per dm cube multiply by the MR. MR of what? MR of the solute. Because you're talking about solution, right? So the MR refers to the solute, the sugar, the salt, whatever you dissolve in it. And you get an answer called by MR. It's 180, which is given to your glucose. Right? So 0.4 times 180 is just substitute 0.4 plus 0.4, 180, 180, and then you multiply out, and what is the answer? Right? What is the answer? So the answer should be 72, right? And if you're not careful, you will think that it is 72 is the answer. Yeah. But why did I not say 72 is the answer? Because because when we express in using this formula, most for DNQ and gram percentage, we are saying in per liter, per liter. So in this case, I am not finding per liter. I did not make a solution make up per liter, right? I make a solution from 50 centimeter cube, 50, not 1000. And if I want to make a solution that's 1 liter, then yes, it is 72. So if it's 1000 liter, centimeter cube, which is 1 liter, then I have to use 72 grams. But if I only want to use 50 centimeter cube, should I also use 72? No, right? Because you to get the same amount of concentration, you don't need. How are you going to figure out how much do I need? So simple mathematics will ask you to do this, right? So simple mathematics will tell you take 72 divided by 1000, right? And then multiply by 50. Okay, so this is mathematics. You have to um, uh, one or two minutes to figure it out. Okay, if you cannot get it. So yes, the answer is 3.6, not 72. So this may be a little bit tricky. Let's go to 28. Dissolving ammonium nitrate is endothermic. Endothermic means there's a drop in temperature. If it is a fall in temperature, the heat, did it flow to the surrounding or flow from the surrounding? So the loss in heat is because the heat flow to the surrounding outside the cup, outside the beaker. That is why when you measure the temperature of the reaction, there's a drop. 29. Okay, I need to go faster. Hydrogen peroxide decompose. Decompose means break down, so you have a gas. The lumps of manganese are added to hydrogen peroxide. Increase the speed. Increase the speed doesn't mean it increase the amount of product form. The volume of production oxygen gas over time is shown on the graph. Okay. What change in condition produces line Y? So X is the original, right? Okay. Then what will cause it to be like y. Okay, now let's look at the possible answer. Which change in process y? So obviously y, yes, I can see it's a bit faster, but it also produces double the amount. Now please take note whether you increase the temperature, increase the concentration, put in a catalyst, right? It will not increase in a higher amount of the product form. So y has higher volume of gas. It will not do that. Increase the speed doesn't mean more product is formed. I repeat, increase in speed doesn't mean more product is formed. So increase the temperature means faster the temperature, but faster the reaction, but it will not cause an increase in production of Y. Let me do, how about this one? Using powdered manganese oxide. Powdered manganese oxide means the catalyst has larger surface area. It also increases the speed, but it doesn't improve the double amount product. Okay. Using half the volume of the same concentration of hydrogen peroxide and using the same volume. Now, if you want to use the same volume of more concentrated oxide, you will produce more Y, or if you use half the volume of the same concentration. Which one you produce more product? More concentrated means more moles, isn't it? So although you use the same volume may contain more moles of hydrogen product. So for example, this one you use 1 mole per km cube. If it is 1 mole per km cube, you get 0.5 moles of oxygen produced. If you use 4 moles of hydrogen peroxide, then you get 2 moles of oxygen produced. Right? 2 is to 1. So whenever this is doubled, you get more oxygen. If you use half the volume, same concentration, you should get less, right? You should get less because um, because you have less moles. Okay, so maybe you start doing here. So if you want to be more precise, it's more moles of the limiting. So in this case, there's only one reactant, so that is the limiting reactant. There's no excess because look, there is no other reactant over here. Okay, so maybe it take a while to understand. Okay, the third one, sorry, 30, aqueous iron chloride, okay, brown, oh, okay. So can you remember something? This is a reduction and oxidation question. Okay, so, oh, I saw aqueous potassium iodide. This one over here. This region here is confirmed Ra. Okay, you put this in your memory. And this one here is a confirmed O.A, oxidizing agent. You see that? So only oxidizing agent and reducing agent, when you react together, they will form some color change or a product will be formed. So let me see. This one react with this one produces a brown solution. So brown solution simply means iodine is formed. That means there is a reaction. There is a reaction over here. So this must be a OA because only OA will react with RA. Can you get it? Because there's a brown solution means there is a reaction form. And in order for a reaction to form, OA must be react with RA. Then you may ask me, what happens if there is no brown solution form? If there is no brown solution form, that means there's no reaction. That means this is not OA. Okay, it can be RA or can be simply neither both. Not OA. That's all. Look at the second one. Aqueous produce pure yellow. That means this is purple in color, and then the pure yellow orange solution is formed. Now you don't have to know what it is, but what you can say that's a reaction is formed. Something is formed, right? How come you know it's something is formed? So because this one over here is purple deep purple deep purple in color. So there is something formed, and therefore this must be R dot A. So RaOA. So here iron 3 is OA, right? And iron 2 is this one. Which row of an acid is correct? So Mr. Low go faster now already, yeah? So products with a reacting metal acid, reacting metal salt and hydrogen, yes, correct. Okay, but carbonate cannot be hydrogen, right? Yes, carbonate is only salt, water, hydrogen. Yes, so answer is B. And unknown metal oxide is insoluble, is a metal oxide. Exo is a O, okay. Once I know it's amphoteric, I know the famous three, right? What are the famous three? Zinc oxide, lead oxide, and aluminum oxide. Okay, aluminum oxide. So if that's the case, amphoteric oxide, if you can remember, will react with acid to give a salt, will react with hydroxide to give a salt. Okay, one, two, three, four. Okay, that means either A or C is correct. Let us see. The effect of adding universal indicator, no change. That means neutral, turns blue. So, do you think these are basic or acidic? Right? Because they are metal, they are basic, they are not acidic. All metal are basic oxide. Okay? If you cannot remember this, go to acid and bases lesson notes on the course. R and T are group 1. Group 1 is very famous for low melting point. Okay, so R has a melting point of 98. T has a melting point of 63. That means T is lower than R, the melting point. So can you remember as you go down, the melting point decrease or increase? As you go down, it's decrease. When you decrease, that means T must be higher, greater. Yeah, T has a greater, larger proton number, okay? Larger proton number. So if it's a larger number, R has more? No. R has less? Less? A could be correct. R is more reactive? No. R is more reactive. R is 98. T should be more reactive. So group 1, the lower is more reactive. So D is wrong. C is also wrong. How about A? R has less electron shell. Looks okay, right? Less outer shell electrons cannot be because all of them are from group 1. Right? All group 1 have the uh, same number of the shell most electrons. So 34 three metal atom metals XYZ like PQRS. Find your the order of activity. Okay, they never tell you what is the identity. The results are shown in the table, no observation. Tick means got observation, X means no reaction. That means not reactive. So which look at X. Everything got no reactivity. Like X don't react with P oxide, X don't react with Q oxide. That means X is very weak. Right? X must be a non very low reactivity matter because the more reactive matter, maybe I type it here, more reactive matter, okay, this is what is the meaning. Okay, so obviously X is the least reactive, and you can do the second one. Why cannot displace R? I cannot displace R. Right, so in case you don't understand the table image is X when reacted with P oxide, P oxide, okay, it means no reaction. The table means like that, okay. So when Y react with R oxide, so I put there Y reacts with R oxide. So you look at the Y with R, the plus no reaction, so it's also no reaction. Okay, this is the meaning lah. This is the meaning of this table. So that means this means Y, alright, uh, it's weaker, right, weaker than R, so it cannot displace it. And let's look at the third one. Z can displace P oxide, can display R oxide. It cannot, sorry, it cannot. It can only displace Q. So among all the clue here, if Z react with Q, that means can displace Q oxide, that means Z is more powerful than Q. Okay, Z definitely more powerful than X because X cannot displace Q outside. Y can, and so I can put something like that. Z is much powerful than X. Okay, see that? Let me give me another statement. Like X is very big. So now let me see how about X and Y. Okay, Z and Y, sorry. Z and Y. Y can displace P, Y can displace Q, Y cannot displace R, but Y can displace X. Okay, so Y looks very powerful, right? Because it can displace the matter from outside. So although it's not directly X, Y, Z, uh, if the question is X, Y, Z, and S outside, it's much easier. But this one is a bit tricky because this is not X, this is not Y, it's not Z. But still, we can deduce from here that Z can displace greater than X only because Z can at least displace Q. But X cannot even displace any other one. So if you look at this logically, the only answer is C because Y is more powerful than Z. Y is more powerful than Z. Okay, Y can displace Q, Yes. Just take some time to understand. Question 35 is no longer in your syllabus, but if you want to know the answer is the okay. Okay, this one is a typical tricky question. The figure of sign. Origin of air is 50, but what you need to know, the important thing is uh, the normal air contains 21% of oxygen. So in this case, when copper is heated here, all the oxygen here and here is used up. All the oxygen that I highlighted here, all the oxygen here all used up because the copper will oxygen. So if it's originally 50, that means there is 50, 50. So let me put it simple, 20%. What's 20% times 50 centimeter cube? So how much of oxygen is that? Right? Is it 10? Right? Is it 10? So that means 10 is used up. If 10 centimeter cube is used up, right? So look at, so how should it look like? Do you think 10 is only used up, or that means left with 40, right? That left with 40 centimeter cube of air because nitrogen will not be used up. Right, nitrogen will not be used. This one is not. This one is 40, 40 amount of air is gone because oxygen is only 20. 20% is used up, 21%. All right, so 10, that means 10 centimeter cube is gone. So that's why it's 50 drop to 40. Uh, I don't understand why a physics question is here, but never mind the typo error. Let's go to 38. The diagram shows a fractionating column. Okay, this is nothing but memorization. So R have to be bitumen, right? R has to be bitumen. Maybe Q. Q is diesel or petrol. I think P. P is the higher one is petrol and then is diesel. Okay, this is the answer. This one you can just check it out. It's memorization. Chlorine and methane. So what type of reaction is this? Substitution, right? Also memorized by heart. Okay, look at organic alkane. Okay, so yes, it's substitution. You need ultraviolet light. Again, this is a factual question, recall question. Okay, you need ultraviolet light and substitution. No more. Okay, last one is called polymer. Okay, then there's a monomer. Monomer all have double bond one. Okay, monomer has double bond. Okay, but but not but not necessary to be alkene. Anything that has a double bond for any molecule that's unsaturated can undergo additional polymerization. Okay, so double bond, alkene is double bond, but not all double bond molecules are alkenes. Just like a dog has four legs, but not all four leg creatures are is a dog. Okay, so when you see this type of question, I think your teachers have taught you, you do this first, right? You circle the, yes, you circle the 2 by 2 first, okay? So you just ignore the rest of the and then you concentrate on this one of the circle one. Then you bring this, imagine you bring this back, you bring this bond back. Okay, so you see a C double bond C like that. Okay, and then the rest are the same. The rest are the same. So this is the monomer. Okay, monomer. So this is the monomer. This is how you derive from here to here. And this one, I cannot write properly. I just write C2H5. Okay, never mind. You know that this monomer, and you can see that this monomer has 1, 2, 3, 4, 4 carbon. And how many hydrogen? There's 5, 6, 7, 8. So this is the answer. So I hope that this explains the MCQ for you for 2022.